Okay, students, now whatever we are covered in the envelope detector, now you understand the complete idea of the envelope detector, right? So, how a simple circuit it is, what are the advantages of the envelope detector, why we concentrated that much on envelope detector for saving cost, complexity, simple circuit, easy to implementation, okay? So, to gaining all the advantages of the envelope detector, so there is some limitations of the envelope detector that also you are covered, okay? So, that also you can understand. Now, after completion of all these things, I just give a few points here, okay? Now, a few conclusions here is, now you know that, okay? You just see one by one. The demodulation is possible only when mu less than 1. Am I not? So you know that when mu greater than mu equal to 0, there is no modulation at all. Am I not? So mu must be greater than 0. And in the envelope detector, if you want to do the demodulation of AM signal by using strictly envelope detector, mu must be equal to 1 or less than 1. Okay. And output of the envelope detector is, you know, this is the output of the envelope detector because AM signal is nothing but AC into 1 plus Ka m of t cos 2 pi ft. Now this is the output of the envelope detector. Okay. So the demodulation is possible only using envelope detector when the condition is mu less than or equal to 1. Okay. Now the second point, when AM signal, when AM, this is these 2 points which we are already having experience. Okay. When AM signal is over-modulated. Over-modulated means mu is greater than 1. When AM signal is over-modulated, what happens? That negative side voltage will also move to the positive side. Plus 5 volts is as is 5 plus 5 volts, but minus 5 volts will become to plus 5 volts. So the negatives will become positive. Therefore, the modulus of AC into 1 plus K into M of T is the output of the envelope detector when AM signal is over-modulated. Over-modulation means what? Now AM signal is over modulation means mu is greater than 1. You know that. Okay. Next, a DC component. Am I not? Now, why we are using the envelope detector? We are successfully using the envelope detector at the receiver side. Now, only the condition is at the transmitting side. Now, message signal is added with a DC component. Then go for modulation with the help of carrier. Am I not? So, a DC component is added to the message signal and multiplied with the carrier to generate a AM signal. But what is the condition? This message plus DC, this message plus DC. Now this is completely positive in nature, am I not? So after adding the DC, the message signal should not be below side of the time axis. The message signal after adding DC, it is completely a positive side. Now above zero level, okay, above the reference level, greater than or equal to 0, such that the demodulation is possible by using envelope detector. Otherwise, if this is not positive, if you add a DC component but message plus DC is not positive, then the demodulation is not possible by using envelope detector. You know that. Next, what is Ka? You know that you already have Ka, mu, which is equal to Ka into AM. What is AM? Amplitude of the message signal. So Ka is used to normalize the peak amplitude of the message signal. This is the peak amplitude of the message signal, such that the modulation index should be always less than or equal to 1, and the demodulation is possible by using envelope detector. Am I not? You know that. So if there is no Ka, then the normalizing is not possible, and there may be a chance of mu is greater than 1. Okay. Next. Then what is the concept of envelope detector? The envelope detector is tracking. It will track the envelope of an AM signal, because the envelope of AM signal is nothing but the message signal. So the charging and discharging time constants are proper in such a way that you can get back that envelope. So here the charging, you already know that the charging time constant should be as low as possible, but it is already low. The discharging time constant boundaries should be like this. The discharging time constant of the envelope detector should be as follows, because now you know that the discharging time constant RL into C, the discharging time constant should be as high as possible. The discharging time constant should be as high as possible Now this is compared with the time period of the uh, charging. So what is the time period of the charging? Because RL into C, which is far greater than, now what is the time period? See here, this is the AM signal, right? Now in AM signal, now what is this? This is the carrier frequency FC, this is the carrier phase phi, because the frequency is FC. Therefore, this is the time taken to complete full cycle is the time period. What is this time period? Is nothing but 1 by FC. Generally, what is 1 by FC? Now FC is very high, so 1 by FC is very low. Therefore, this is RL into C, which is very high compared with the charging time constant. So can I write like this? The discharging time constant should be very high compared with the charging time constant. So RL into C is far greater than TC is nothing but here. This is the TC is a small value. So 1 by F. This is one condition. And this is the maximum. What is the lower limit? So this discharging time constant should be the time period of the message signal. Now this is RL into C, which is the time period of the message signal is 1 by FM. This is the time period of the message signal. This is CM, time period of the message signal. So these are the conditions such that this charging and discharging are properly in such a way that to track the signal. Okay. So this is the lower limit. RL into C is far greater than 1 by FC. This is the upper limit. RL into C is far less than 1 by FM. Okay. Sir, why this condition? If this condition fails, what happen also we will see. So if RL into C is less than 1 by FC, now tracking is not possible. Why? Because now this charging and discharging over a carrier frequency, because in AM signal, the frequency of the AM signal is FC. Okay. So finally, this should be the boundaries of the envelope detector. Now 1 by FC less than RL less than 1 by FM. This is the suitable time constant for the envelope detector. Otherwise, the tracking is not possible. Now in your mind you have some doubt that, so what happen if these conditions are failed? That's what I write this one also. Now see here. Now this is the AM signal, AM wave, amplitude modulated signal. Now this is the charging, fast charging, slow discharging, charging, discharging, charging, discharging, charging, discharging. This is the time period of the carrier, right? Now see here, if this condition, which condition? RL into C, see here, this RL into C is far less than 1 by FC. If this is not possible, now the tracking is, the envelope signal is not possible. If this condition is not satisfied, tracking is not possible. See here, what happened now here? Now, if, and some of the students are asking that, sir, what happens, sir, if RL into C, now why it is only less than, RL into C is why, what happen if RL into C is greater than, sir, why RL into C is far less than 1 by FM. Now what happens if it is greater than, listen, if RL into C is far greater than 1 by FM, now this will be happening. See here, now this is the discharging time constant. If it is greater than the time period of this, now see here, this portion is missing. See here, now this tracking portion is missing now. See here, this portion is missed portion. Here the information is available. Now this information is lost, this information is lost, this information is lost. Now these things will be happening in the discharging condition. Now this RLC into C is greater than 1 by FM. Now if RL into C is greater than 1 by FM, what happens? Now these things will be happening. Understand or not? If RL into C, this is, here I will write, RL into C is greater than 1 by FM, this portion is missing. This is the untracked portion, means some information is lost. Okay. Now this is due to the discharging mode. Now in the tracking mode, this is somewhat like a diagonal. Therefore, this particular condition is called as diagonal clipping. If this condition is satisfied, the diagonal clipping will occur. The diagonal clipping means some of the information is lost diagonally. Now this is the untracked portion. Understand or not? Now that is the reason why if you want to save this particular information, to avoid diagonal clipping, the following conditions should be to avoid diagonal clipping. Now this should be the conditions must and should be satisfied. Now to avoid diagonal clipping, now the following conditions should be satisfied. Okay, RL into C is greater than diagonal clipping will occur. So RL into C is far less than 1 by Fm, no diagonal clipping, nothing. Okay, if this condition is satisfied, then the diagonal clipping will not occur. Now, if this condition is failed, then there is a chance of this missed portion. Now, RL into C is this is 1 by omega m time period of the message signal, and it is also a function of modulation rate. Now, some of the students are asking that, sir, when mu changes, what happens? When mu changes, definitely this V maximum, this is V maximum, and this is V minimum. So you already have an experience, case 1, case 2, case 3, am I not? Now mu is greater than 1, mu is less than 1, mu is 0.5, mu is 0.6. Now when mu changes, definitely this maximum amplitude and minimum amplitude is also changes. Okay, when mu changes, this V maximum and this V minimum is also changes. So when mu changes, V maximum and V minimum is changes. Now when V maximum changes and V minimum changes, now V maximum, V minimum changes, then definitely there is a chance, okay, to avoid this diagonal clipping. But what is another problem? When mu changes, the another problem arises is V maximum, V minimum is changes, and to avoid the diagonal clipping. But the problem here is there may be a chance of mu greater than 1. Am I not? There may be a chance of mu greater than 1. If it is a mu greater than 1, then there is no demodulation. So because when mu changes, what happens? No. If mu changes, no demodulation. Using envelope detector when mu is greater than 1. Or sometimes when mu changes, which means that now there is no demodulation. There is no modulation at all. There is no modulation when mu equal to 0. These things will be happen when mu changes. Okay, so that is the reason why mu changes, V maximum, V minimum is changes, then automatically this tracking portion is also untracking portion is tracked. But this should be the conditions now when mu is changes. Okay, and to avoid diagonal clipping, RL into C is far less than 1 by Fm, and RL into C is 1 by Fm and square root of. These are the conditions to avoid diagonal clipping. Okay, one small problem we can explain based on this condition. Now first you note down this each and every point. Classroom workbook, question number 13, I think. Now classroom workbook, question number 13. Now what is the question? A carrier signal of 1 megahertz and a message signal of 2 kilohertz. A carrier signal of 1 megahertz and a message signal of 2 kilohertz are formed to generate an AM signal. A carrier signal of 1 megahertz and a message signal of 2 kilohertz are formed to generate an AM signal and is applied to envelope detector. and is applied to envelope detector and for getting message signal as output of the envelope detector, what is the suitable time constant? What is the suitable time constant of the envelope detector? What is the suitable time constant of the envelope detector? And options are also given here. Now the options are 1 microsecond and 20 microsecond and 0.5 microsecond and 400 microsecond. What should be the suitable time constant of the envelope detector such that you can get back the original message signal from the AM signal? Okay. Now this is the question what he is asking. Okay. Now we can easy. Now here this is the suitable time constant of the envelope detector, right? Now RL into C, which is far less than 1 by FC. What is FC? 1 megahertz. Now far greater than 1 by, sorry, this is 2 kilohertz. Now 1 by FC is nothing but 1 megahertz. Therefore, now 1 microsecond RL into C. Now 1 by 2 is 0.5, 500 microsecond. RL into C, which is far greater than 1 microsecond, and RL into C, which is less than 500 microsecond. Now this is the condition, which is greater than 1 microsecond and less than 500 microsecond. So this is the suitable time constant, which means that it should be greater than 1 microsecond. So it is not the answer, and it should be less than 500 microsecond. So greater than 1 microsecond means this is also not the correct option. So only one correct answer is greater than 1 microsecond means 20 microsecond. Okay, this is the suitable time constant of the envelope detector such that you can get back the original message signal. Okay,